Thanks. Well, I thought I would tell you a little bit about a journey that I have been on kind of since I was a kid, working on computation and trying to make computation kind of realize the potential that I think it has. I mean, I started off using computers when computers were as big as this to try and do science, and I ended up being fairly successful at doing that, and then I ended up using a bunch of that science to be able to do more things with computers and computation, and I've been kind of on this journey of doing basic science and building technology ever since. So actually, for the past 30 years, I've been kind of systematically building a very definite kind of intellectual and technology stack that has turned into what we call Wolfram Language. And I guess there are two things that you hopefully might have seen over the years that have come out of this intellectual journey of building the Wolfram Language. One is Mathematica, the other is Wolfram Alpha. So Mathematica gets used in R&D and education and so on. It's kind of, it's been really nice to see over the last 28 years since it came out, all sorts of inventions and discoveries and so on made with Mathematica. It's been really a wonderful experience seeing that happen. Then, about 8 years ago, we brought out something which seemed, on the face of it, like it might be an impossible project, but one of the things that's a great advantage that I have of having a private company which doesn't have investors and so on to answer to is that I get to work on crazy projects that might not ever work out, because it's only me who loses if they don't. So we started building Wolfram Alpha as a kind of consumer-based system to take natural language input and be able to generate answers based on curating lots of data about the world. So that's been a very successful thing. It powers things like Siri and so on these days. There are actually kind of two branches of the Wolfram Alpha world. One is the consumer Wolfram Alpha, which works on public data and where people ask natural language questions, get natural language, get reports out based on public data. There's a second, perhaps less well-known in the general public branch of the Wolfram Alpha world, which is building enterprise versions of Wolfram Alpha for large organizations. There are a bunch of these that have now been built across a lot of different industries, financial industry, healthcare, retail, lots of kinds of things. And actually, starting kind of this year, there are a bunch of production systems in the world, which many of you will probably interact with, that are actually have Wolfram Alpha running inside, taking natural language input and generating output. So but the kind of the real story underneath both Mathematica and Wolfram Alpha is the Wolfram Language. That's the thing that Mathematica is based on. That's the thing that Wolfram Alpha is built with. And one of the things that we've been concerned with in the last few years is building an environment that lets us realize the sort of full potential of the Wolfram Language. And I'm happy to say that I think we're pretty close to having built out what we really want to build out in that area. It's kind of what one might call a sort of hyper-architecture. It goes across desktop and cloud and embedded devices and mobile and supercomputers and so on. It's a kind of a uniform environment for deploying Wolfram Language. Actually, this week happens to be the release of a thing we're calling Wolfram 1, which is kind of a way into this technology stack. And I'll talk a bit more about that, but this is basically the first example of kind of access to this sort of hyper-architecture powered by Wolfram Language. So one thing I want to sort of make clear, our products have been used for many years in research and development and education, in consumer stuff, in sort of large-scale enterprise deployments and so on. But the thing that's kind of significant, I think, with Wolfram Language is if you develop software, you should be using it. Maybe some of you do now. Not enough people do. I wander around this convention center and so on. I talk to people, and it's like people tell me what they're doing with software and so on. And it's like, you should be using Wolfram Language because it will be an awful lot easier for you to build what you're trying to build. So I want to tell you a little bit about Wolfram Language. And my main message is, you should be using this. You know, I have a successful company. We've done lots of good stuff. We don't need you to use it, but you should be using it. It will be good for you. It's I think one of the things to understand also about my company is that, again, I've done something kind of unusual. I mean, it's still a fairly small company, about 800 people, but I've kind of optimized the company for kind of intellectual value rather than for commercial value. That's been great as far as I'm concerned, because it's been a great sort of machine for taking ideas that I have and turning them into real things. But it means that we haven't done all of the kind of high-pressure sales and so on that you might have seen given the kind of technology stack that we have. All right, well, let me actually show you some things here. So let's kind of start up Wolfram Language, Wolfram Desktop here. And let me see, is this large enough, or should I make this a lot larger? Larger, okay. There. Let's try 200%. Is that better? Yeah, okay, good. All right. Well, let's see. Okay, good, that works. So I thought there's so many things to show in Wolfram Language, I'm not quite sure what to show. Actually, yesterday I did kind of a combination live coding and mentoring thing for startups, and so I thought maybe I would pick a few of the things that we've done with some of the startups that I was talking to. Let's start off doing something. I don't know, where should we start? The point about Wolfram Language is to try to automate as much as possible, to try to be able to deal with all kinds of data. There's a nice image here. Let's say I make a let's take that image. And for example, let's figure out the distribution of colors. Okay, there's a whole bunch of blue in that image. Maybe I could take that image and I could say something like, how about this? Let's try taking doing some operation like this on the image. Okay, I might have to adjust the image. Still not very exciting. Let's see what happens if I colorize that. Okay, a little bit more exciting. I'll tell you what, let me make this a current image, and let me make this whole thing dynamic. And let's see if I can get something more exciting to happen here. The thing to understand about what's going on, this is all just, okay, that's a bit weird. Okay, not too exciting. The kind of the idea of Wolfram Language is do something very different and much more ambitious than has been done in previous computer languages. Try and build as much knowledge about computation and about the world as possible right into the language. And one of the things that I've spent much of the last 30 years doing is kind of keeping coherent the design of the language. So instead of having a small core language and lots of random libraries built by different people, the idea is to have everything be integrated and to automate as much as possible. Another key idea of Wolfram Language is that it's a symbolic language. So if I have something called X, it just says, okay, that's X. If I have an image, it's just an image. I can manipulate things symbolically. There are many ideas in Wolfram Language which have been sort of ahead of their time. I think one that's become popular these days is these notebooks. I mean, this was an idea that we introduced 28 years ago, and I guess now there are rather inferior versions of these notebook constructs that are starting to pop up other places. It amazed me that it took 25 years for that to happen. There's an awful lot of other stuff in Wolfram Language which is still far in the future in terms of what other people have been trying to do. But let's start looking at some sort of more real-world things. Here's the thing I was doing. Okay, so let's pick I said we can deal with real-world kinds of things. So let's say Los Angeles, the city. That's an entity. We can say what's the population of Los Angeles. We'll know all kinds of things about it. Let's say, for example, we want to find out, this was based on something I was doing yesterday with someone. Let's say we have Los Angeles. Oh, actually, let me say, I want to know what are the nearest mountains to Los Angeles. So let's say I want the 10 nearest mountains to Los Angeles. Okay, so this should give us 10 mountains. Let's say I make again, these are just symbolic entities that represent mountains. I can say, okay, make me a plot of where those are. Well, now let's say I want to make this into a sort of piece of production software. Let's say I want to make an API that shows me where the nearest mountains to a place are. So I could say, I can make up something where I can make a form where I say, okay, there's going to be a location, and it's going to be of type location. Let's see here. And I'll take that little piece of code from here, and I'll say, show me, let's say, make a geolist plot of this thing, and let's take this and replace that with just whatever the thing that was entered. for the location was. Oops, I have to spell it right. Then it will turn the right color. There we go, OK. So I'm going to make that plot. I'm going to say it's going to come back on the web as a PNG. OK, so now what I want to do is I want to say deploy this to the cloud. And then I'm going to say, let's make this into an absolutely public thing in the cloud. So let's make this public here. And then I'll say, deploy that to the cloud. This will now create a little web app. So let's go there. And now I'll start browser. OK, so now I've got a little web app that's asking for a location. And so let's say I type in some location. It's going to use natural language understanding to figure out what that means. Let's say I type Eiffel Tower. What should happen here, assuming we have network connectivity? OK, there we go. That wasn't so illuminating, actually, but that's a picture of the 10 nearest mountains to the Eiffel Tower, and we could elaborate it in all sorts of ways. Let's say we want to turn that into an API that we could use from something else. We just say, instead of a form function, we say it's an API function. So now we'll get something which, if I just give it without a parameter, it will just give an error. But we can say location equals, let's say LA, for example. And now it will run that API in our cloud and give back a result. OK? So, and I could go ahead and take that API. I could make, say, show me the code that I would need if I wanted to put that API in a Java program or something like this. And that's, so this is what, I mean, the thing that's important is you go from kind of the idea of what you want to do to an actual piece of working code in a very short space. And we can do all kinds of things. Let's do something different. Let's say, how about we do this? Let's do some machine learning kinds of things. So let's take, I don't know, what can we do? Let's say, how about we do this? Let's try and take, anybody got a favorite kind of object? Let's take a chair, for example. Let's say I'm just going to use an external API here. I'm going to get in 10 thumbnails of chairs, hopefully, assuming that we can communicate here. Come on, network. And then I can use kind of, OK, so there are some chairs. OK, let's see what happens if I say, let's try and image identify these things, see what our neural net thinks those things are. OK, it's got to download some kind of classifier that it's using, and then wake up. And hopefully, it's going to tell us something about what these are. There we go. OK. So it's decided those. So for example, let's pick one of these chairs. Let's say we can kind of see inside the thing, image identify. We can take that chair, and we can say all possible things, 10 possibilities. Let's say, what are the probabilities for different things? And it'll tell us the different possible identifications that it makes for this. So we can do all kinds of elaborate things here. Let's say we want to look underneath this. One of the big things that we've introduced recently is kind of a symbolic representation for neural networks. And so we can say, let's take net model, and let's say, so this is actually the network that is underlying that image identification. So for this is, we can actually see in here, there's a lot of detail of this network. This is a network that's been trained, so we can say, if we take that chair and we feed that chair to this network, it's going to tell us it's a lounger. OK, great. Now let's take that network and let's say, let's look at the insides of what the network is thinking. So I can go here and I can just, let's go to, I don't know, let's take just the first 15 levels of this network. So now I will have truncated the network, and now I can take that thing and I can feed that truncated network this particular chair. And now I'll get some giant, what the heck is this? Let's see, what are the dimensions of this thing? So now I'm going to get, OK, a giant array that's like that. Maybe I can make a 3D image of that. So I can take this. OK, that's not very illuminating, but that's something sort of inside the mind of the neural network, so to speak. That's part of what it was thinking. But we can go, the important thing here is that we can manipulate things like this neural network in a purely symbolic way. And we can see all kinds of interesting things here. You know, it's really, when you start seeing sort of the whole world of data, I don't know, we could, for example, let's take the word computer and let's translate it into lots of different languages. And maybe what we can do here, let's see what happens if I say, let's just do this. Say, Let's get the first word for computer in each of those, and let's maybe do, what can we do here? Let's say the values of this, and let's, for example, let's try doing a feature space plot, and let's see whether we can, let's just do it for the first, let's say, 50 of these. And let's see, okay, so what that's doing is now it's in feature space. It's showing us how these different words for computer from these different languages, I never tried this before, it's kind of interesting actually, how these different words for computer cluster with respect to these different languages. So lots of different kinds of things we can do with Wolfram Language. So how much time? Oh my God, I'm almost running out of time. Okay, so let me sort of talk about a little bit about the bigger picture of this. So the idea here, as I say, is to kind of automate everything, to try and make it so that if you kind of understand what you're trying to do, our job in building out our language is to make it as automatic as possible for you to be able to do that. Whether you're doing 3D printing with all kinds of geometry, whether you're dealing with some giant network and studying how that works, whether you're doing machine learning, whether you're doing some kind of fancy visualization, image processing, whether you're processing financial data, whether you're doing natural language understanding, geography, all these kinds of things. The idea is to have an integrated system in which all of those things can operate, and also to be able to do it not only on the desktop, but also in the cloud. So for example, here, I can just go to the cloud, and that same notebook mechanism that I was showing you, we can also use here in the cloud. So I can just start typing into this web browser, and I will get the same kind of notebook that I have on the desktop. Huge amount of work to actually get this whole notebook technology that we've developed over the past 30 years to also work in JavaScript in the cloud, but we've now succeeded in doing that. That means you can deploy all sorts of interactive things right in the cloud, and you can embed them in other places and so on. Let's just do one thing here, if I could only spell. Let's just make a trivial interactive object here in the cloud. Let's see here. This is a trivial thing, but I can sort of automatically produce this user interface and then make it active there. So it's been my kind of goal with Wolfram Language is, as I say, to sort of build in to kind of a knowledge-based language where I'm building in as much knowledge about the world as possible. Sort of the ultimate goal is to have a language which the computer can think in terms of, and you as a human can also think in terms of. It's sort of important that it's kind of a very open code kind of language, because the little pieces of code that you're running, these are things you can actually read and go from a piece of code that you saw somewhere and be able to work from that. One of the things that's been interesting is that this language has been widely used in kind of the high end of the R&D sector. It's also now a language that one can teach even to kids as a way to kind of understand computational thinking. And so I put a lot of effort recently into kind of taking this language and using it as something to teach to kids. There's actually a book I wrote, this is the second edition that just came out, which is kind of an introduction to the Wolfram language intended for kids and others. The thing that's exciting at sort of an educational level is that you can now kind of teach computational thinking in an environment where all of the kind of mechanical details of coding have been removed, and you can also sort of work directly with things that you might think or care about, because all the data and all the knowledge is built directly into the language. So if you're a software developer, for example, and you say, okay, well, how can I actually start using this? The answer is you can go to the front page of our website and you can press the thing that says immediate access. If you're a kid learning programming, press the Programming Lab button. If you're a fancy experienced software developer, press the Development Platform button. You can just start using it. You don't even have to log in. And you can just create a new notebook and get going. You can also look at, there's a fast introduction for programmers, which is about 15 pages, that tells you kind of the basics of how to understand Wolfram language code and how to start going. Wolfram language has a lot of ideas in it that are kind of, that I think other languages have been slowly moving towards in some ways, and actually there are a lot of things which it's easier to explain today in Wolfram language than it was 25 years ago, because people have now heard of lambda functions and things like this, which they hadn't 25 years ago, unless they happened to use Lisp, for example. But our goal here is to really be able to take programming and to take the use of computation to kind of a new level, because we've tried to automate out all of the kind of details. Within my own company, one of the things that I find sort of spectacular is we'll work hard on automating things. That's why I've been able to have the company be as small as it is, because basically it's lots of clever computers and a bunch of clever humans as well, but the emphasis is on the clever computers. And it's always remarkable to me, you know, there are projects that we've been doing where we had to write them in Java and JavaScript and Python code and God knows what else. And these projects, they take ages and they take a couple of months, and I get very frustrated. And then I say, this is the kind of thing we're going to do repeatedly. Let's automate it. Let's just put it into Wolfram Language. And we finally do that, and it takes a lot of effort. But okay. Oh, that's turned red. I'm sorry. I'll stop in just a second. Anyway, the thing that that then we finally automate it, and it's really a neat thing, because what used to take what used to take those 2 months and be very painful suddenly becomes a thing where you can just write the code and get it done in an evening, and other people can read the code, and it's really a neat thing, and it's been something that it's very nice to see all these pieces coming together. Well, so I hope you guys will actually be able to use this. It's something where we're starting to see kind of the hackathons getting won with the kind of magic of Wolfram Language. Lots of large companies starting to use it for all kinds of projects. A bunch of startups using it too. Not as many as should be, and I hope we can change that. And if I want to say, let me know if it works here. You can just send me mail. I was going to send myself here. How about I send myself that picture as a kind of reminder of this talk? But please, by all means, I've been working in this direction now for 30 years. I think I hope people will find what we've done useful. Certainly, lots of good things have been done with it, but not as much in software development as should have been. So I hope we can change that. Thanks.